Algebraic Reasoning, Chapter 3.1, Exercise 1 through 12. Chapter 3 in our book has to do with inverses of functions. And so in this set, I'm going to go over about half of these problems. Use the table to answer questions 1 and 2. And here you have a table, and it says generate the inverse of the linear function. And then 2, determine if the inverse is a function, explain your answer. And so really, this boils down to this section. You're having the concept of what an inverse function is. And essentially, it can be described many different ways, but one way is that independent and dependent variables are switched. And so I'm going to rewrite this as a inverse function, and I make an xy table, and x's become y's and y's become x's. So this coordinate pair, -1, -2, becomes, as its inverse, the coordinate pair -2, -1. And then similarly, we do the same thing here. We take 0, 1, it's going to be 1, 0. Then 1, 4 becomes 4, 1. 2, 7 becomes 7, 2. And 3, 10 becomes 10, 3. And really, that is the inverse of the linear function as described here in this table. So that becomes our answer to problem number 1. Okay, so now we go on here to, I want to go ahead and make a little sketch of what's going on here. Okay, we have an XY coordinate plane. So just a kind of a graphical representation of what's happening with the inverse function. So we have the point 1, -1, -2. So there's -1, -2. So there's 1 point right here. 0, 1, that's going to be a y-intercept here at 1. We have 1, 4, so over 1 to the right and up 2, 3, 4. So there's 1, 4. Then we have 2, 7, so go to the right 1 more and then go up 3 more. So 2, 7 is going to be right here. We have 3, 10, so 3 and go up to 8, 9, 10 up here. And so you can see a pattern here, can't you? Looks like a line. And now for its inverse function, we take -2, -1, so -2 and -1 will be right here. Doing this in red. 1, 0. That's our point. 4, 1, so that's 1, 2, 3, and up 1. So there's that point there. 7, 2, so 5, 6, 7, and up 2, so it'll be about here. And then 10, 3, 8, 9, 10, and go up 3. So we have this. So what you have is the inverse function. Inverse function the other reflect about the line y equals x, which I'm now drawing in that dotted black line. So that's going to be y equals x. So graphically, that's what these tables look like transcribed onto a coordinate plane. Determine if the inverse is a function. Well, the main thing you're going to look for is, I will say, yes, the inverse is a function because there are no repeating x values. So they will pass the vertical line test. We haven't talked about vertical line test in a while. Yes, the no repeating x's in table. No repeating x's in table. X's, plural for x, in table. And then you could bring in vertical line test. You can see the vertical line test is passed. You can run the vertical line. See, vertical line touches that red graph only once. So that is our answer to problems 1 and 2. Now, what you're going to see here in problem 3 and 4 is another table, but it's for a quadratic function. And so a quadratic function, the graph of a quadratic function is going to look something like this. Okay. Well, the inverse of that function is going to look something like this. Okay. This red one. Well, is this red one a function? No, it's not. So you may, when you get your, actually you are going to see it. You're not going to, anyway, too much hinting. 5 and 6 generate the inverse of the cubic function, similar to what we did earlier on problems 1 and 2. So we just say, okay, well, I'm going to make this do this faster. So just reverse, say -3, comma 2, comma -3, -1, comma -2, -1, comma 0 becomes 0, -1, 0, comma 7 becomes 7, comma 0, and 1, comma 26 becomes 26, comma 1. So that is the inverse of that function, problem 5. Okay, determine if the inverse is a function. Yes. Why? Same reason, no repeating x values in the inverse, that is. One concept I tell my pre-calculus students is that the inverse of a function is not always a function. In this case, looks like it is, according to the data we have. And that's as far as we're going to take that one. Okay, 7 and 8, we have generating inverse of an exponential function. So you have an exponential function and just what an exponential function looks like. I'm not sure this is the case for this one. Exponential function is going to look something like this. Okay, and the inverse of that function is going to look something like this. Put it in red, so just what it looks like. Okay, use the equation and graph below to answer questions 9 and 10. And what I think I'm going to do, and since this video is going through 12, we kind of covered a linear function in problem 1, at least what it looked like. I'm going to go ahead and go to do in this video lesson problems 11 and 12, which are of a quadratic function. So to generate the graph of the inverse of the quadratic function, what I'm going to do for this is similar to what I did for problems 1 and 2, 5, and 6. I'm going to transfer this to a table or create an inverse function via a table. And so I'm just going to make a note here, that's inverse function. And this point -8 comma 10 becomes 10 comma -8. -2 comma 0 becomes 0 comma -2. -1 comma -6 becomes -6 comma -1. 0, comma, -8 becomes -8, comma, 0. This point 2, comma, 0 becomes 0, comma, 2. And if you notice, the x-intercepts, okay, these are x-intercepts in the original function, but become y-intercepts here. See, x-intercepts in the original function become y-intercepts over here. So I'm drawing the arrows to the table. Okay. And then also this down here in the original function, this y-intercept becomes an x-intercept right here. Okay. Now generating the graph, I'm just going to leave everything here. I'm going to put it, change my color, make it red. 10, comma, -8. So that's going to be to the right 10. So, and the aspect of this graph is not exactly right, in that you look at the x values will take just the aspect, will have more weight on this, more graphically proportionally accurate is not there. So it's almost like a 2 to 1. So, but anyway, that's going to be, you're going to see that on the graph. It's going to look a little different than it would for a normally proportioned graph. You'll see pretty closely. Okay, so we have 10, comma, -8. So that's going to be okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right here in -8 will be way down here. Okay, so that's going to be 10, comma, -8. 0, -2. So 0, -2 is going to be right here. Next we have, I kind of got that wrong, don't I? That's -3, -8. So that's not exactly right. Let me fix that. Okay, -3. Okay, that's going to look better. -3, -8 is going to be about right here. So I'm going to put that in red here. -3, or excuse me, 10, -3. There, that looks a lot better. That's way down there. Didn't look right. Okay, now we're back on track. Okay, there's that second point, which is 0, comma, -2. Next we have -6, comma, -1. So we go to -6, comma, -1. There we go. Next we have -8, comma, 0. So let's see, 6, 7, 8. So -8, comma, 0. And then we have 0, comma, 2 right here. 0, comma, 2. And the graph of that's going to look like this. So we're talking about a sideways opening parabola. Okay, so that's what it's going to look like. And this red horizontally oriented one looks skinnier than the vertically oriented one, the blue one, just because the aspect of the graph is different. So that's 11 done. Next, determine the x-intercepts and the y-intercepts of the original function and the x-intercept and y-intercept of the inverse of the function. So we already identified that's going to be of the inverse function, that's going to be x-intercept. which is going to be equivalent to the y-intercept of the original function. So the relation between those two. And then we have the y-intercepts of the inverse function. These are y-intercepts here. I'll circle in purple. Y-intercepts of the inverse function and the x-intercepts of the original function. So I just circled them and I kind of explained what they were on the graph a little bit. But the takeaway is the x-intercepts and y-intercepts of functions versus their inverse functions are opposite. So that should be your takeaway. Anyway, good luck and thanks for viewing.